Our next speaker, while he gets his computer set up, is David Levy from Scitara. Topic of his presentation is transforming lab connectivity to leverage data value. David is currently the VP of Strategy at Scitara, and he's worked in the industry for over 30 years on product and global account management at several companies, Waters, New Genesis, Cambridge Soft, and PerkinElmer. So David.
Thank you very much. All right, good morning, everyone. It's a pleasure to be here, and I've already met a number of folks that I've had the pleasure of working with over the past few years, or at least know. I want to thank the Merck team and Cy and Amanda for their presentation. My presentation kind of builds on that a little bit, provides a little bit more context, and Dana will maybe address some of the questions that you had about linking results and raw data in the course of the conversation. So we're going to move along at speed. If anybody has questions, please stop me. I think, what I'm talking about here is something that is very familiar to everybody. And so we can cover a lot of ground pretty quickly here. So point-to-point integrations, I think everybody knows, it's been happening for 30 years. It has a lot of challenges. Technically, it's feasible, but it creates all kinds of challenges of scaling. Right? It also creates challenges around validation if you're in a validated environment. It also creates challenges around penetrating the protected layer that most laboratory instruments typically work in. Not the least of which is that many of these types of dynamics have prevented other business applications, platform applications, from getting access to data that comes out of the laboratory, which is also very challenging. So the Scitara approach has been to address some of these problems. In fact, we try to address them all by creating a commercial grade infrastructure that really solves this challenge at two layers, right? We're going to start first at the transactional layer, which is the basic exchange of information across the entire laboratory ecosystem. And then we're going to talk a little bit more about some of the benefits from our perspective of ASM and generating real value from the data that you're transacting. So if we establish, if you will, a horizontal commercial grade integration platform that works across the entire ecosystem, that includes technologies that support the ability to cleanly communicate in a secure way from the protected laboratory environment out to the cloud. Scitara Digital Lab Exchange is a cloud-based platform. We have components of the technology that are required to be inserted into the lab because certain instruments require downloaded agents in order to work. But through the technologies that we have evolved, we're able to very securely exchange information across that cloud boundary. And this includes items like, for example, the cloud e-notebooks, LIMS, MRPs, et cetera. It also creates an environment where, let's make sure that we're in the right place here. It also creates an environment that provides not just connectivity, but automation. So if we think about the way that a platform like this would need to work, not only do you have to connect to everything in the laboratory, but you want to automate that process. That process might involve a series of steps, right? And we use the terminology orchestrations. Orchestrations are a series of steps. They involve connection steps to different resources within the lab. That includes people. It includes the ability to transform data, right? So there's a lot of discussion around the concept of fair data. The native language from the Scitara DLX perspective is JSON, which fits in very cleanly with allotrope simple model. Since that's how we're already transacting. So the connector technology talks to the instrument or the software platform in its native language, brings the data in, converts it into a JSON payload and transacts, and then reconverts at the other end. So, and that can involve multiple steps, right? So we can send data in multiple directions at the same time. So this is a mechanism for executing a series of transactions. If you're in the LIMS system or in a Revity Signals or Benchling and you want to send data somewhere and receive it, there's a mechanism that allows you to do it. I've got some short videos that'll give you a sense of what the user experience looks like when you're doing this. The ability to build these orchestrations is designed to be available and accessible to our customers and partners. So we do not need to be the ones that build these orchestrations. In fact, we don't really want to be in the ideal world. This needs to be a self-sufficient platform that our customers and our partners can take advantage of. So the idea is to create this unified control plane, if you will, for moving data around. It uses modern tools, modern technologies. It's extensible. It can be deployed. It's designed, in fact, to be deployed in a validated environment, but it can be deployed in a non-validated environment as well. Well described. And because now this data is in a more universal format and structure, it provides the ability to communicate much more easily with other systems that don't normally talk to the laboratory. And that could be, for example, something like MuleSoft or other applications that are out there that don't typically work in a laboratory environment. So effectively what we're doing is creating a digital core, right? And everybody has, I'm sure, digital transformation projects, at least one that's going on, right? So we're providing a digital core that allows the entire laboratory ecosystem. And we are very specific about providing a portfolio of tools and technologies that really does not leave any instrument or software application behind. Because if you're only digitizing a portion of your laboratory environment, you're not really doing a digital transformation project. All right. So from a transactional point of view, what does this look like? So this is, I've got a link at the top. We recently did a webinar with our partners at Agilent, and it's great to see so many of our partners here as well. We do partner with pretty much almost everybody in the ecosystem. And so this is a quick video of creating a sample list in the Agilent Open Lab sample scheduler application, which was and you'll see if you watch carefully that there's an action, a button that is clicked inside of the Revity Signals application. That basically we extract information through the connection, through the Revity connector into our automation stream. We transform the data in flight and it gets put into the sample scheduler. And if you noticed, right, these two fields, sample status and analyst ID, were blank. So once the sample list is created, it returns data back to the requesting platform, providing status. Now, on the next step, and this really kind of goes along very similar to what Cy described. Hang on a minute. Hang on. We already did this. There we go. Okay, now let's try this again. So on the return trip, right, when the analyst is done, and a lot of this is configuration and is also very user dependent, right? Cy showed the ability to load data automatically without user intervention back into the LIMS system. This does basically the same thing. This example here, basically when Agilent Open Lab completes an analysis, that is reflected in the sample scheduler. We can read that trigger and automatically bring the data back, both as individual results, as well as providing graphical information. So this is a PDF, for example, of the report. We do have customers that are a little nervous about that. They don't like that automation. And so it is possible to effectively execute the same process, but with a user interaction where the user has to go into the platform. It could be LIMS, it could be eNotebook, and actually push a button to go fetch the data and pull it back, right? And or there's in between scenarios, right, where we could detect that the analysis is done, send the user an email with a button that says, hey, this analysis is done. If you want to take it on board, click here and proceed, right? So there's a variety of different user interactive steps. The key thing here is that workflows are very different everywhere. Everybody has their own way of doing things, and the platform has to accommodate for that. All right, so let's talk a little bit about moving from transactional value, right? So the transactional challenge of managing data exchange across the laboratory is a real problem. We've worked with many, many customers. It has a tremendous value and tremendous benefit of automation and time savings and all that kind of great stuff, right? But everybody, how many of you have a data lake? I know the Merck team has, everybody has a data lake. How many of you have more than one data lake? Right? Okay, not surprising. And one of the key things and one of the real benefits we see of allotrope simple model is solving a real challenge that a lot of our customers have around, well, how do you build a data lake? There's no instruction manual for, everybody wants to do their own unique thing inside of that data lake, extract their own nuggets of gold out of that data. The data model that you use to build your data lake is the starting point, or multiple data lakes, because it may take more than one. That's a starting point that is key. And one of the great things that allotrope simple model provides is a consistency of documented structure that you can use to build as a starting point for your data lake. So you always know what the incoming data is going to look like because it's documented. So this is an example of another workflow that we're working on right now. And I'm going to show you two examples of it. It's not a video, but it's this. In this particular case, we're working with the Merck team on an osmometer that at the moment that actually has OPC functionality, but it has custom OPC codes. So our OPC connector doesn't support it right now. So we're modifying the connector as we speak to add in those custom codes. This is not uncommon. Unicorn is the same. For example, Unicorn uses OPC to exchange data back and forth, but they have their own unique Unicorn e-custom codes that are in there, and you have to incorporate those and support them in the connector. So what we're doing in the short term is we're going to do a file exchange, which is a great example because there are still a lot of applications out there that simply don't support automated integration. So in this particular case, you can see this workflow, and this will be made available. This presentation is available for everybody to look at in more detail. The idea here is that as the data comes out, it can be automatically swept into a secure environment, which we call the data store. So it doesn't have to live and sit out on a Windows file share. It can, if that's what you want. We can take that data then and compare it to the sample that was initially submitted, right, in the store sample list area. There's metadata here, and then proceed. And you'll notice that not only are we sending the result back to LIMS, but just like Sai showed, we're creating an ASM version and dropping that into a data lake as an ASM structure. The difference between doing something like that and fully automating through an API is significant because now you can actually have an exchange, almost a dialogue with the instrument, right? You can send the instrument through OPC a set of instructions. The instrument receives those instructions. The user executes those instructions on the instrument. And when the data is done, it either comes back directly automatically or it gets pulled back as we talked about before, right? So ideally, and we've all talked about this, I know a million times, we're going to eliminate files. We're going to get rid of files, right? And here we are in 2024 going on 2025, and there's still a ton of applications out there that generate files. So we're going to have to live with that for at least a while, right? So, part of what we're looking at doing is, well, what can we do to mitigate that? What can we do to at least come as close as we can to this more automated workflow, even if there are files involved? But this transition from transactional value, which is great because it saves time, less filling, tastes great, less filling, all that good stuff. It's important, right? But what about the data that's flowing through the pipe? Where does it go? What format does it take? What format does it take? What do you want to do with that data, right? So what we've started doing is talking about a couple of different scenarios. First of all, taking a step back to talk about the, from a transactional point of view, if we want to put data into a data lake, it's not hard. You add a step onto your orchestration. Great. But is that really the most efficient way to do it? And when you think about all the different things that people want to do, and I'm going to skip ahead here a little bit in the interest of time, think about all the different things that people want to do. This is me sitting down in about 15 minutes and just writing down all of the different use cases that I've had customers over the course of working for a few different companies ask me about over the last, let's say, 5 to 10 years. There's plenty to do. There's a lot, right? Is one data lake going to accommodate that? Maybe, maybe not. That's okay. That's okay. It doesn't, you don't have to restrict yourself into a single repository. You can identify the types of data, the format of the data, what you want to do with the data, and you can create from a Scitara DLX perspective as many data lakes as you want. So how do you get the data in an efficient way? How do you continue to maintain the transactional value of what you're doing in the lab and get the data into a data lake in a more efficient way? And so the idea here is to separate the data lake insertion from the transactional step using, again, modern tools that are already out there. So we're creating what's called the fair data stream. And the idea is that, I think we can advance this a little further, is to create a separate subscribable, it's a mouthful, sorry, service. So you can transact using traditional Scitara DLX orchestrations, but you can have your data lake subscribe to Scitara DLX to extract out of our database content that meets specific criteria in an automated way. And so it completely separates those two things. So it makes your orchestrations easier to modify. You can manage how the data gets inserted into one or more data lakes in a completely separate step. It also speaks to, and I'm going to come back here to the linkage between raw data and results. It also speaks to the importance of grabbing the data that you want. There's a little bit of thought involved here in these configuration steps, right? So the data that was inserted, for example, back into Revity signals, or if it's Sci put into LIMS, that's what LIMS wants. What your data lake wants is probably a superset of that data. You're going to want a ton more metadata. If you're doing chromatography data, you might want information about, peak width over time. If you're trying to do predictive analytics around instrument failures, what's the first thing that happens when a pump starts to go sideways? Your peaks start to move around, or they get wider, or they get narrower, all kinds of weird behavior. If you want to start tracking that using AI, for example, or machine learning, you got to have the data. So what this allows us to do is to capture a broad volume of data, parse out what it is that the transactional model needs. So the LIMS only gets what LIMS needs. The instrument only gets what the instrument needs. But your data lake can pull from a much deeper array of data so that you can do that analytics. And now this slide is a bit of a mouthful, but or eyeful, but so bear with me here for a moment. But if you think about the transactional piece, right? And if you want to do, so all of the data that flows through our system is searchable. And that includes results. You can add labels. And so while the transaction's going on, I'm just going to go ahead and expand this out. Your data lake is subscribing through the annotated data stream to pull a different set of information. Now, from a transactional point of view, many systems do share information. You just have to dig for it, about the instrument that generated the data. So going back to your question before, we're typically transacting a lot of result information back and forth. We're sending instructions out to instruments and software. We're receiving back result information, various different payloads, reshaping that, in the case of the Merck team, into ASM, and dropping it into an S3 bucket or a data lake, or could be Snowflake, right? There's nothing that prevents us from going out and grabbing the associated binary data file. Let's use chromatography as an example, right? If we know the instrument ID, right, which many of these, whether it's, Chromeleon we know does it, Empower does it, I believe OpenLab does it as well. If we know the ID of the instrument, we can go fetch that and store it in an S3 bucket, right, or other suitable location, and establish a link that could be living inside of a LIMS or inside of any notebook or even inside of a data lake. So it is somewhat dependent on the ability to get the information about what's the instrument ID that generated that data, or the location of the raw data file. But in many cases, that raw data file location is available, and it can be incorporated into the automation. So effectively, what we're building is an infrastructure that can connect to all the instruments in the lab, normalize the data into a consistent format like ASM, right? Drop that data into one or more data repositories with the idea of not only solving the transactional integration problem, but also, well, what do you want to do with that data, right? There's been a lot of discussion and great presentations. Bill had a great one earlier about what are you going to do with the data? How are you going to generate value from that data? And everybody's going to have their own model. Our role in this is to basically be a driver of high quality, context rich information into your repository of choice so that you can do those kinds of things that you want to do. Now, this has an interesting dynamic to it as well, because there's a lot of talk and a lot of discussion around AI and what are you going to do about AI and all that kind of stuff. And you know, what we're trying to accommodate, and when we see the Scitara role as far as AI is concerned, is to try and develop a different kind of relationship or dialogue between the scientists in the lab and their instruments. So if you think about the way orchestrations work today, typically it is folks in the lab IT organization or super users, but you know, particularly in a quality environment, you don't want people changing orchestrations all the time. You want to develop a process, you want it to be repeatable, you want when somebody pushes that button, the same thing's going to happen every single time. Right? That's what you need. You need that control, right? What AI provides, though, interestingly enough, is a way that you can get a little bit more intimate, if you will. You can actually talk to your instrument in a sense, right? And if there's time, and if you guys are interested, I've got a little video that kind of illustrates that. But the idea is that and the question is, how do we want to use it, right? So this is something that's in development. It's prototype ready for deployment to work with customers that are interested in exploring this. But if you can talk to your instrument or talk to your e-notebook and say, create a sample set in Empower, right? Or a sequence in Chromeleon, or take this balance weight. Is anybody really going to do that, right? Is that a sensical thing that somebody in the laboratory is going to actually do? Maybe, right? Quite possibly. The interesting thing about this is when you think about, and we call it project strands, when you think about what this creates is an opportunity to incorporate some of these tools not only into the Scitara platform as an IT user to help you build orchestrations faster, because that's great. And anything you can do to help build orchestrations faster is good. But are there activities, are there tasks in the lab where it really does make sense to let the user interact directly with an instrument? There might very well be. And if you can do that, and you can do it, especially in a way that's well documented, right? Is that something that we want to pursue? So the way that we're doing this is we're working with a variety of different large language models. Strands is LLM agnostic. What we're finding is, for the moment anyway, that ChatGPT is still the one that has the best function calling, right? So we're not trying to, you know, solve world hunger inside of DLX, but what we are doing is adding tools, as they're called, so that a ChatGPT in a controlled environment, this isn't like the broad, everybody logs in and says, you know, how do you make soup? In a controlled environment, you can send ChatGPT to a tool to, let's say, create a sample set in Empower, or to add a table to a row in your notebook. So these structured responses are pretty interesting. And what this does, and I'm going to speed up here, again, in the interest of time, is it creates the ability for us to interact, let's say, either through Scitara DLX or even through a completely separate user interface, and call these different tools. So you can see some of the examples on the right-hand side, right? That, you know, we can call emails, we can call timers, we can call different aspects of Scitara. So you can ask, for example, one of the ones that we've been working with quite a bit that is very attractive is talking to bioreactors and basically saying, hey, you know, so monitor my pH or dissolved oxygen or whatever, and if it goes above or below a certain level, send me an email. And you know, so you can kind of keep track of what's going on for something particularly that might take, you know, a week or multiple weeks to go. So this is an interesting dynamic, and it adds some really interesting possibilities in terms of how do you want to use AI, right? Interactively within the laboratory space. What makes sense? What doesn't make sense? So we're developing a set of capabilities and functions that we want to work with our partners and our customers to understand how is this really going to work? What is it that really adds value? As we all know, just because you can do something doesn't mean we should. So we want to spend a fair amount of time and make sure that that as we go down this path, that we're going down this in the right way. We've also applied user roles, our role group model for security to this. So for those folks, that one of the very first things that we heard loud and clear from our customers around AI is, wait a minute, hold on, how do we apply a reasonable security model to this? And we believe that it absolutely can be done. It does take a little bit of thought. It takes a little bit of effort, but it definitely can be done. So here's some just examples of things that we see as possibilities for AI use, whether it's an assistance inside of DLX, potentially, call out as a step in an orchestration and automation, or even as a, in a lab co-pilot kind of an environment as well. So I hope this has made sense and puts a little bit of additional context around the presentation that Cy did. What we're really focused on here is establishing that transactional platform, that digital core for the laboratory, and create a highly confident data delivery mechanism through a variety of different vehicles, right? Whether it's the data stream or through orchestrations, to not only solve transactional problems, but also create that high quality context rich data pool for tools like AI, machine learning, et cetera. So with that, I'll say thank you very much. I'm happy to take any questions if you have them.